By the end of today's video, you'll be able to build your own fully functional and compliant rubber band robot intake. I'm Brogan and I've been teaching robotics and design for over a decade now. And today I'm going to step you through step by step with all the parts you're going to need to be able to build that rubber band intake to pick up a sphere up and off the ground nice and easily. And I'll even give you lots of tips on building throughout the way. So to get started, you're going to need some sort of drive base. I like to have a lot of extra space on the sides here so we can have our points up. I'm using a Swift drive base here. It doesn't really matter which one you use, to be honest. In terms of all the different parts you're going to need, you're going to need a few different tools. You need a 2.5 mil and a 3 millimeter wrench or hex wrench. I like to use a set of pliers. You can use a crescent wrench, whatever it is that you need. You're going to need a few different 10-tooth sprockets, but honestly, any 1-to-1 sprocket will work. A couple of different small half pillow blocks, 17th length, and a couple 10 or 11 length. Really just something long, honestly. That's just for this prototype. You find something that works for you. Then a very long axle with some couplers. I didn't have access to a coupler, so effectively what I've done here is I've taken a sonic hub with a through hole through it that goes into threaded holes, and then I can clamp onto both of my axles that are coming apart. You'll need some long rubber bands, thick, thin, doesn't really matter on this one, some chain, and then a few different 3D printed parts here. This is a 3D printed part that's actually going to move our whole unit up and down with some different slots so we can get different heights. And then this is the actual rubber band wheel itself that can either fit onto a hex-shaped shaft or into a hub-based system. And then lastly, of course, you need a motor. I highly recommend for an intake, good rule of thumb is you want something that runs twice as fast as your actual drive motors. Because my drive motors are 435 rotations per minute, I want to make sure I'm using a 5-to-1 ratio on top of this ultraplanetary, so I can end up with about a 1200 RPM, and that's kind of what I'm going for. It's a little bit more than double, and that allows me to basically take it and own it. So we need some sort of support structure on the side of our system here. So we're going to go ahead, take these, and we're going to build them up. So we're going to find some clear holes that we can run some 8 millimeter systems through. So I'm going to take an 8 millimeter screw, go to mount it through like so, and let's tilt this up so you can also see what it is that I'm doing here. And I'm using lock nuts for everything here. And in the future, I might actually change that. I'm going to do it like this on the other side so that I can actually screw in from the top without just destroying my fingers. Now I'll grab my 3 millimeter wrench. Now because I'm just doing this as a temporary solution, I'm only going to put in 2 on an angle here, but you should definitely put in 4 as your mounting holes so that these things do not come apart on you in the middle of your robot driving around. That would be very bad. We're going to grab another one of our 10 holes, make sure that we match up. And as I'm matching this up, I want to make sure that I have good clearance against my drive wheels, because you do not want your drive wheels being scraping something. That would be a recipe for disaster. Now, as I'm threading this thing, what I'm wanting to do is I'm getting these kind of hand tight first, because what you'll find if you tighten all of your fasteners right at once, or tighten one of your fasteners first to start and then come back in later and try to get another bolt in, is that you're going to run into the fact that your holes don't line up very well. So by adding that in, that helps your holes line up. We're going to add in one of these long PCU channel. This is going to help constrain our system together. This is a 17th length, which is the same size I've got for my main system here. And here is where we get to use our small little pillow blocks. These guys have threaded holes in the inside, so you want to make sure you're using a bolt that's not too long. Using 8 millimeter screws for all of this. Make sure that you find a hole that's going to line up so that you're nice and flush with your unit up from the top. You can tell that in the past, somebody's cut this PCU channel down, but they've cut it at a standard length so that it does make these easy to line up and make sure that I am still nice and flush as I run this down. Now, before I throw on this top unit, I'm actually going to mount my motor on now at this point. Now, You can use a Go Build a motor, you can use an Andymark motor. It does not matter what supplier you use. I like to stay platform agnostic if I can. So I've actually got Swift channel here with Go Build a parts, and then I'm using a Rev Robotics because I like to use the parts that work the best for what I need. Nice thing about these Rev Robotic parts is that Go Build a actually sells a little adapter here that you can swap onto the motor. And then you can also add an adapter here that allows you to attach these things to a U-channel piece. So with that, I now have 4 threaded holes here that I can mount my motor up nice and high. And let's put our motor mount in the top hole here. Put our threads in on this side. And I'll get you a better angle at this so you can see. Now these things aren't actually going to fall out. I'm going to mount this with 4 8mm screws in each of these respective corners. Again, I like to get these finger tight to start. And once they're finger tight, then I can come back in with a tool and clamp them down so that I can make sure that my motors are actually lining up properly. There we go. At this point, we can also go ahead and add on our sprocket, which is where we need our 10mm. You can use a mounting hub sprocket as long as it's 1-to-1. I have 2 little set screws here that I can put in, and these guys just help constrain our axle. So I'm going to put that on so it basically touches the U-channel. Then I'm going to back it up just a little bit so that I am not scraping on the U-channel itself. And we'll give these set screws a good little snug. You don't have to completely destroy these set screws though. That's a mistake some people make, is they constrain those set screws on way too tightly. So now it comes time to decide roughly where this ball should end up going. So what I'm going to do is I'm going to line this up on the ground. I'm going to take one of my main rubber band wheels, slap an axle through it, and we are going to want to move this in such a point that we can start this at a hole where we're actually going to be overlapping. So in my case, it's 1, 2, 3, 4, 5 holes up from the ground is where I'm going to decide to place this, because that's where my ball and my rubber bands start to actually overlap a little bit. And we can change these heights by either changing this system up and down with these couple of bolts down here, or we can also have a slot base where we end up with a bit of play in here as well as some larger plays that we can move in. And the reason we can do that is because this whole system is going to slide inside of 2 little holes here, and this whole system here can slide up and down inside of our U-channel. And if we were to run our axle through, we can actually move the whole thing up and down, move it down another major hole, move it up and down. I like to design with compliance in mind because you don't know right from the start just how much compression you need on some sort of intake. So using that is really going to help us out here. So we're going to be 5 holes up from the bottom. So I'm going to count it 1, 2, 3, 4, 5 holes. We're going to place this system in like so. Now this system here is designed in such a way that I can drop a few lock nuts in, and I might only just use 1 lock nut in this case to constrain it inside. I'm going to grab a couple 10mm screws here, and we should be able to just drop a lock nut right in like that. Pop in a bolt, and then start threading in. And I'm not going to completely clamp this one down yet because I still don't know where exactly my ideal compression is going to end up sitting. So I'm just going to get it, basically exactly in the middle of that 5 hole. We'll repeat the same thing on the other side. We'll drop that lock nut in, and as I thread that in, we can now give that a little hold, give it a little clamp. Oops, I keep grabbing my 2.5mm. And we'll give it a little compression like so. We'll go ahead and repeat the same thing up at the top. In this case, I'm going to flip it around because it makes my life a lot easier. And we'll go 1, 2, 3, 4, 5 holes up. Grab that section. Grab a couple more 10mm screws and a couple more lock nuts. And we'll drop this directly in the middle again. And we'll thread in another one of those holes. Like so. One thing about this design is because you're using slots, you're going to want to check to make sure that you are actually even across your rubber band intake. So use some measurements in that respect, because it's entirely possible that you could design this in such a way
that, or put them together in such a way that you are not level. Okay, so we're now nice and snug, and we're ready to actually build the main axle now. Now, one thing you want to keep in mind on these and with these 3D printed parts is I like to print these out of PCTG. It's kind of a bit more of a more impact resistant PETG, and I quite like it as a material. I've been pretty impressed with it, but these ones you could definitely laser cut out of acetal. You could laser cut out of plywood, make it 8mm, whatever it is you currently have access to. Now, for the next part of our system, we can actually start putting our main section together. So I'm going to grab a couple of sonic hubs. These ones have threaded holes in the inside. And we're going to mount them basically straight onto our points like this. You can grab a few 8mm screws to go through our PCTG mounts here and then thread right in to that sonic hub. So we can give ourselves a little bit of extra. Now, if you are going to use a sonic hub, make sure that you're lining up so that your hex does align up, because it would be possible for you to line these holes up in such a way that your hex hole does not actually line up correctly with the unit. So make sure that you have lined this up properly. These ones, the tolerances on these holes are also designed in such a way for a laser cutter and not a 3D printer. So you might find as you're threading these in that you actually end up expanding these holes slightly because they're going to start to tap into that. But it should be pretty good for the amount of tolerances that you need without being a full clear hole, but should be pretty good. So we're going to make up these couple of sub-assemblies. We're going to make them the exact same with each other. We'll do the same thing on this side. Make sure that my holes are going to line up here, and in this case they are. So I'm making sure that that hex hole is lining up. Because otherwise you're going to take this whole system apart after you just put in 4 screws, because you'll attempt to put on your axle and be like, oh, it doesn't fit. And it should be frustrating. You could also easily redesign this. Take the step file if you want to. Take a look in the description down below, join my community, you get the step file. Then you can modify this yourself, make it a D shaft, make it a round shaft, make it a 5mm hex shaft, whatever it is you need. This is currently just a 7mm hex shaft. I believe that the Go Builder Suppliers calls it an 8mm Rex, but it really is a 7mm flat to flat shaft. So it's effectively the same deal here, just with a different fancy name. All right, so now comes time to have a very long axle. And I do not have access to an axle that I need that's long enough to actually be able to constrain ourselves through this entire system. So what I've done is I've got a few long axles here, and we're actually going to combine them together using this coupler design that I've made up here. You should use a proper coupler. I don't have access to one. So I have through holes on this D shaft, threaded holes on this D shaft. You clamp them together. And what this lets you do is this lets you have this side clamp onto one axle and this side clamp onto another. So I'm going to take this axle, I'm going to put it through about halfway through my system, and then we will clamp that down. And then we'll take our other axle, we'll put it about halfway through that system again, and then give that a clamp down on the other side. So now you've got a nice long axle that's not going to come apart. And we can go ahead and actually mount on the next part. I'm going to grab a ball bearing. This is a flanged ball bearing. So we're going to have the flange facing out, and we're going to have this sonic hub clamp against and constrain against this system. So we're going to pop this ball bearing in on the inside of our spacing right there. Slide in our nice long axle. Oh, actually, before we slide in a nice long axle, we need to put our sonic hub on in such a way, like so that the sonic hub's going to be facing against the edge there. And we're going to use a shim. And we're going to slide that on like so. And because we're not ready to do that side yet, I'm actually just going to leave that like that. And we can put on our second system now because we want to be able to slide through and still give us lots of room to play with here. So now I can build up that second section here, and looks like somebody's taken out one of my clamping screws. I'll put a 12 millimeter in back like so. Now in this one, we're not going to clamp this one down all the way yet because we want to put in our half system here. Oops, and I'm putting that on the wrong side. We want that to be able to be on the other side, so the sonic hub is facing towards the edge. So we'll clamp this system down on 1 and 2. Now we'll go ahead and marry these two sides together, and we'll do another clamping system with 1 and 2. At this point, I can now take another flange bearing and another shim, put my flange bearing through, take my other point, and slide it through like so. So I end up with a nice, long, constrained system. Now, before I clamp these down, I have no idea if these sides up top are parallel. That is where this top system comes in to be able to clamp on like so, to be able to hold us nice and parallel. So I'm going to grab a couple 8 millimeter screws, and we will now go ahead and thread in from the top on both of these so that we end up being nice and clamped in. And we'll do the same thing on this other side. And we'll clamp to the top of that pillow block so that we know that we are nice and parallel. All right, so now we shouldn't be able to flex this in and out anymore, which is what we're looking for. So let's go ahead and spin this around so that we can see things a little bit better and see the actual intake a little bit better. So now we need to make sure that we have enough outputting space here. Obviously, this is not a finished prototype, so I'm just going to keep this somewhat in the middle for now. And now I'm going to take my fingers, I'm going to push this way with my thumb as I go to clamp this in. And give it a little clamp, give this a little clamp, and then the same thing over here. I'm now going to squeeze these two sides together as I go ahead and clamp these in so that I end up with a nice constrained system. There we go. I'm pretty happy with that. And now we have a nice straight piece. We can tell we've got a little bit of bend in that axle. Somebody has clearly bent that axle over time. It's not a huge deal. But now if we were to take these screws and loosen them off, we would be able to slide this whole system up and down. And let's actually go ahead and do that a little bit now, just so that you can see how we go. So now we can actually take this whole system and we can actually slide it up a little bit as we need. And we end up with quite a bit of play to be able to move this whole thing. It still moves straight, but we end up with quite a bit of play to be able to move it up and down in these 14 millimeter holes. So we end up with about 9-ish millimeters of play as we go that way. So we end up with a bit there. And then what we can do is we can either cut one of these sections out so we can get more play, or we can move this things by 8 millimeters, and then we'll have another section that we can play with. So we can move the whole system up and down with a little bit of compliance in that respect. And that's just going to make your design so much easier. The second last step here is grabbing another 10-2 sprocket that we're going to go ahead and put onto this hole here. Again, same deal here. We're going to put it on here, and then we're going to back out just a little bit so that it doesn't go on there. And I'm only going to set one screw in because now it comes time to work with some of our chain. Well, I'm going to be using plastic chain in this tutorial, and it's great as a prototyping tool. I really like plastic chain because it's just so fast to get up and going. So what I'm going to do here is I'm going to wrap this around, feel for where I need a chain link to break. I need a chain link to break right like so. I can take my screwdriver, a flat slot screwdriver, give it a little twist in, give it a little twist, and then that pops our section out. I have a full video on working with chain down below that you can take a look at. And now you'll see the reason why I decided not to fully put this chain on, because I'm going to cheat a little bit. I'm going to slide this on my sprocket now, put it on my axle, and then we can cheat this around. And actually, now that I think about it, I might just move this whole subsystem back to be able to cheat this more. Because putting plastic chain on when it's in place can be a bit of a struggle, but not if we move our whole system through like so and cheat. Because now I can slide it on easy without having to worry about that. And we can slide our whole system through just so we're somewhat even on this. And we can go ahead and constrain our whole system down again. So I'm going to constrain my sonic hubs down first. And we're fighting the torque of this motor a little bit. So it might not be super clean to rotate because now you're spinning through your chain. Put it there and clamp that. And I'm going to make sure that I back this sprocket off a little bit as I put in the 2 different set screws on this sprocket here. And we'll run this one more time. And there we go. So our system is just about done at this point. The last thing we do is start thinking about our rubber bands, stretching them between the 2 systems here. A couple schools of thought with the rubber bands. What some people like to do is they like to cut them and then give them a tie to be able to put them together. What other people will do is they will just take more of them. You can take these rubber bands, loop through on one side, loop through the second side, and now as you pull, you'll end up with a bit of a knot in the middle, but that's okay. And you'll have a nice sort of section here. Now it looks like my rubber bands 2 is actually going to be pretty good for mounting myself through my holes here. I'm going to make sure that I also bend it backwards so that it actually folds up nice and inside my sections there. So we now have one that's now nice and neatly constrained. Let's go ahead and do the same thing across all the others. Now I have made 10 total rubber bands here. There's 10 little slots in my design, so I'm going to have to make sure that I whip up 10 of these systems. We've now got our nice finished rubber band intake. And we can see that as we drive forward into a ball, it's able to collide with this ball, but it's not hitting the inner aluminum rail in the center. And we might find that this is not the quite height we need, in which case we can lift the whole thing up a little bit by simply just pulling on these systems, bring the whole thing up a wee bit, and our chain should still benefit from, our chain shouldn't come loose from this one, but we might find we need to take out a link as time goes by if that does end up happening to your system, and you do end up changing this. But that's what's nice about a chain, as opposed to using a timing belt, is you can swap these things up quite a bit. So let's go ahead and get this thing powered, and let's see how this works at actually pushing our ball in. Now, the last thing you're probably gonna have to add to your intake is some sort of ramp to be able to get it up and onto your robot. So in my case, I've just taken a little sheet of polycarbonate, a little dummy bard here, and just zip tied this on so that as a ball comes in, it can hit our intake and then move up the ball. So that's that all assembled. Let's go take a look at this intake in action. If you'd like to build this yourself and get these CAD files, you consider joining the community down below. If you got any questions, let me know in the comments down below, and I'll give my best chance to be able to answer these out. Otherwise, best of luck with your next robotics project.